Hi, welcome to another session on circles. We have been taking up with theorems as well as some application of those theorems. We now move on to take up theorems on chords. The first one being the simple, it says equal chords of a circle are equidistant from the center. So we have to prove. Let me draw a circle here. We have to draw two equal chords. I assume they look more like two equal chords. Let's name them A, B. This side drew C, D. Let being this center as O. We will have to now say OL. I'm drawing OL perpendicular. It looks perpendicular to CD. I'll also draw one more which should be perpendicular to CD. AB is equal to CD. We have to prove these chords A, B and C, D are equidistant from the center. That means we have to prove OL and OM, the perpendicular distance. When it says equidistance, we mean it's perpendicular distance from the center. We have to prove OM equal to OL. So I write it as the solution. Once you write given, you'd write AB equals CD with center O. We also write OL perpendicular to AB and OM perpendicular to CD. And what do we have to prove? We prove OM equals OL, or OL equals OM. Now to do so, we'll have to join this. I use this color maybe. We'll have to join OA and OC. Why do we do so? Because once we prove the congruency of these two triangles which we formed by joining OA and OC, then by simplicity we can say OM equals OL. So we start our proof here. We write in these two triangles, we name them as OAL and OCM. What do we get? See, angle ALO, we write here. Angle ALO will be equal to angle CMO. They both are 90 degrees because we had already drawn them to be perpendicular to those two chords. The second equality in this, we can write the two radii, that is OA. This triangle is equal to OC. In this, they both are radii of the circle. Now for the third equality, if it seems, I can say CM is equal to AL. I write it here as well. How is AL equal to CM? Now AB is given equal to CD. Half of AB will also be equal to half of CD. Why is M midpoint of CD and L midpoint of AB? Because I'm making half of AB and that I'm writing as AL and half of CD to be CM. Why is it so? Because we know that the perpendicular from the center, these two, the perpendicular to the chord bisects the chord. So M must be bisecting CD as well as A bisecting AB. Therefore AL also equal to CM, thereby proving the congruency by RHS. Once we prove the congruency of of these two triangles by CPCT, we can say that OL is equal to OM. That's what we were supposed to prove. Let's move on now to the converse of this theorem. I write the converse theorem here and then we take on the proof. Chords of a circle which are equidistant from the center are equal. The last one, we proved them to be equidistant. Here it is informed to us that they are equidistant. We'll prove the chords to be equal now. So let me draw two equal chords because we'll prove them equal. Okay, I name them as A, B, C and D. Let the center here be O. We again drop those two perpendiculars as we did in the last one. Hope they look more like this. This is M, that will be N, the center be O. Now we write here whatever is given to us. Says OL is given to be equal to OM, and also we know that OL drawn perpendicular, the equidistance means I told even in the previous one that's the perpendicular distance. So here we write AL perpendicular to AB and OM perpendicular to CD. What do we prove? We prove AB equal to CD. Now if we prove half of AB to be equal to half of CD, by multiplying it twice we can make AB equal to CD. So which is half of AB or half of CD? We can make AL and CM to be equal. To do so, again we draw them, we join this OA and OC to make them, give them two triangles. So what we write in these two triangles, we start our proof and write in triangle AOL and triangle COM. How can we prove them to be equal? Congruent. We say that angle ALO is equal to angle CMO. They both make 90 degrees. We had already said they are perpendicular. OA is equal to OC because they are the radii. It says they are equidistant. That means what? OL is equal to OM. So again by RHS congruency we can prove RHS congruency we prove the congruency of these two triangles. Once you prove the congruency of these two triangles, we say AL is equal to CM. AL is actually equal to CM, and also they are half of AB. Why are they half of AB? Is the same reason. Perpendicular from the center of the circle to a chord bisects the chord, so thereby making it's half of, this is C D. If half of AB is equal to half of CD, then AB is also equal to CD. That we were supposed to prove. Let's move on. Sorry. Now what do we take up? I write, it says one more on the chords again. It says equal chords of a circle subtends equal angles at the center. So I draw a circle here. I again draw two chords, one here and one there. The center will be marked here. Now how they are forming angles at the center will be like this. I'll name them later on as well. I name the center as O. Let me mark the chords to be A, B, and this to be C, D. We have to prove that these two angles formed at the center by these equal chords are equal. So the given part here is AB is equal to CD in this figure. What do we have to prove is angle AOB is equal to angle COD. We move on or proceed with the proof as we did in the previous questions, previous theorems. If we can prove the congruency of these two triangles, then by CPCT we can say that AOB angle is equal to ACOD triangle. So when we start the proof, we write, in triangle AOB and triangle COD, AB, it's not AB, it will be OA is equal to OC. Similarly, OB will be equal to OD. Yes, AB is also equal to CD. That's given. For this we can write they are all radii, and here this is given that the chords are equal. So by S criterion we can prove the congruency of triangle AOB with triangle COD. So by CPCT we can say that angle AOB is equal to angle COD. So this is proved. Now the converse of this will be, see, I won't solve or prove it because it's almost similar to the previous few theorems we have been taking. So I hope you can do it by yourself. Only I will be writing the theorem here. If the angles subtended by two chords of a circle are equal at the center, the chords are equal. This is the converse of the previous theorem. Draw the same figure, only the congruency which you proved in the previous theorem was by SSS, and herein I can give you a hint that the congruency now will be proved by SAS. Thereby you can use CPCT to prove the equality of the chords. Hope you can do that by yourself. Thank you.